What's up, guys? We're going to look at one last thing about our 2048 game. And at the end of the last video, I had it working, but kind of for a silly reason. We added a couple lines that papered over an issue, and sometimes the code works, but not confidently, like you wish you could go back and do a tiny bit more. And that's what we're going to do now. So I'm going to show the thing that was wrong with it the whole time that I didn't notice until the end. And it's based on different types in Python working different ways. So this is a lesson you can take not just for this game, but for anything you use. If we say x equals 5 and then print x, that's going to work the way you think. I'm going to make it a little bigger. Not that big. And it's going to print 5. And if we say there's some other variable in the mix, y equals x, and then we print y, well, it's going to print 5 still. But you might not think when you do this how that works in memory. There's a x sort of pointing to a 5, like when they look up x, whenever x appears in a line, it sort of says, hey, what is that referencing? What's that all about? And it goes to the 5. And now when we say y equals x, that's not a chain. It's not like y points to x points to 5. Y points to the 5 independently. So if the x changes, if I say x plus equal 1, and I print y, well, it's too late. Y is already set as 5, right? The x didn't change the 5, okay? That's what the key thing is here. When we did the lesson on strings, CodeHS really made a big deal to say strings are immutable. I am mutable, meaning not changeable. They're not actually a new thing. If you say message equals hello, and then later you say message equals hello world, it didn't add world onto it. It threw out what it had and made a new association with a new thing. So when I say plus equals 1, it doesn't really take the value, add 1. It takes the value, throws it out, and makes a new thing. And y is still connected to that old value. So that's for strings, that's for integers, that's for a lot of types in a lot of languages. And that is useful for a reason, okay? When they told us about strings and they said, oh, unfortunately, you can't change them as easily as you would hope. You can't just say, like, well, the 5th character is an H now, even though it was an F. You had to do that silly thing where it was like using the colon slicing to go up to that spot, put a new thing, go past that spot, and build a new string. In a list, that's not the case. They are mutable. You can change anyone. You can rearrange them. You can add stuff, shuffle, whatever. But the drawback is they don't work like you think they do, and they don't work like this. So imagine we have a list. Instead of 5, x is now a list with 5 in it. And instead of adding 1, we're adding a list with 1 in it. Now, y is not going to be 5 anymore. Y is going to be both. Okay, y, even though it was never in this line, is affected by this line because x is pointing to the 5, y is also pointing to the 5. And if that thing changes, well, y is still pointing to it, and it sees what the new version is, even if we never said y is changing. Okay? And that's really cool. When a variable is mutable, you can do all kinds of powerful stuff very quickly, but sometimes it'll surprise you. Now, the equals works the same way. The equals is not a new type of rule for these different variables. It's the plus equals that's working a different way. But Another thing is what was getting us with that program, which is there can be another layer. So imagine I said, all right, we got a variable called z, and z is going to do a function. I'm going to make a function called change list, giving it x. So now let's define that. Def change list, and it'll take something, we'll call it listy, and we'll say listy.append hello. Okay, and then return listy. Or even if we didn't return, it would still work. So now, if I hit run, guess what? It's going to be affected by that function, which is like multiple steps away, right? It's like y wasn't in that line, and it wasn't in the function, but it's still being affected because there's only one list in this program right here. And they're all sharing it. So the key thing to remember is that when you're working with a list, there's probably only one. Even if you're giving it different names, those are just different names. If you're working with integers and strings and stuff, they kind of work the way you imagine. They're not, I don't know, sort of in my mind, I think of making copies. They're not really making copies, but if you think of it that way, it's fine. For this, it's not quite anywhere near there. So in our program, we had the 2048 board, and what I was trying to do was to check a possible future by saying like, oh, what would happen if we tried to move this way? And I made a new list and a new function, and I thought it would be completely separate, but it turned out it was affecting the original because of this, because the mutable variables work different than immutable. And it's fine. I added one line to fix it, no problem, but you got to know that in the first place. So this will affect lots of things we do because we use lists all the time. They're great, but they're a little bit tricky.